Hello students, today we'll study the next law of logarithm and that is called as the change of base of the logarithm. Now what is this change of base law of logarithm? Suppose I got a logarithm here, say log of a to base b, and I want to change the base b to some another base c, then I can do it as log a to base c divided by log of the old base b to base c. Take for example, I have got log of 5 to base 3 and say I want to change the base to the standard base 10. So it will be log of 5 to the new base 10 divided by log of the old base 3 to the new base 10. This is called as the change of base law of logarithm. So let us just derive this. I will take log of a to base b at say m. Change this to the index form. So how will you change it to the index form? A is equal to b will be the base of the index form and m will be the index or the power. Now I will take the log to base c, that is the new base I want, on both the sides. So on the right hand side I will use the index law of logarithm. I will get m down and multiply it to the logarithm. So m is equal to log of b to base c. And I will substitute back for m. What is m? Log of a to base b. So now I will take log of b to base c on the other side. So I will get log a to base b is equal to log of a to base c divided by log of b to base c. Now from here I get one result. Now see, I have got log of a to base b. I will change the base to a. So how I'll do that? Log of a to the new base a divided by log of the old base b to new base a. Now log of a to base a, we have already seen log of any number to the same base is 1. So it will be 1 upon log b to base a. So when it is log of a to base b, if I take the reciprocal, that b and a will get interchange. It will become log b to base a. Take for example, if I log of say 10 to base 5, then I can write it as 1 upon log, interchange this two, it will be 5 to base 10. So let us see some of the problems depending on this. So the first one, find significant figures, log 15 to base 9. Now, last time I have already discussed two logarithms on your calculator. One is log log without any base, that will mean base 10, the standard base, and another is ln. So here I will change the base to 10, that is the standard base. So it will be log 15 to base 10 divided by log 9 to base 10, or that is just log 15 divided by log 9. So if I evaluate this on the calculator, it will come out to be 1.23. Okay, let us see another type of problem here. Solve log x to base 6 plus 6 into log of 6 to base x is equal to 5. Now, if you see these two logarithms, this is log of x to base 6 and this is log of 6 to base x. So, x and 6 are interchanged. So, I will use the result here. Log 6 to base x. If I take the reciprocal 1 upon, what will happen? X and 6 will get interchanged. So, it will be log of x to base 6. So, log of x to base 6 plus 6 into, take the reciprocal here, 1 upon log x to base 6 is equal to 5. Now, I will multiply throughout by log of x to base 6 to get rid of this denominator. So, each term I will multiply by log of x to base 6. That will be log x to base 6 the whole square plus 6. Here log of x to base 6 will get cancelled, and don't forget to multiply on the right hand side also. So 5 into log x to base 6. Now here what I will do is I will take log x to base 6 at say y. So I will get y square plus 6 is equal to 5y, which I can write it as y square minus 5y plus 6 is equal to 0, which gives you a quadratic equation. So this is easily factorizable. Find the factors of 6 such that sum is 5. That is 3, 2, and since you want negative 5, minus 3 and minus 2. That means the two factors will be y minus 3 into y minus 2 is equal to 0. Now, equate each factor to 0. So you get y minus 3 equal to 0, which gives y is equal to 3, and the other factor y minus 2 is equal to 0, that gives y is equal to 2. That means two possible values are either 3 or 2. Now put back for y. y is what? Log x to base 6 is equal to 3. Change this to the index form. X is equal to 6 cube, and 6 cube, that will come out to be 216, 216. Then come to the second value or second root. So you get log x to base 6 is equal to 2, which gives you x is equal to 6 square, that is 36. So the two possible values are x is equal to 216 or x is equal to 36. These are the two roots. Now, I wish the steps are okay with you. So keep this particular hint in mind that whenever the terms in the equations are like this, here log of x to base 6 and here it is interchange. So log of 6 to base x. So in that case, take the reciprocal of log of 6 to base x. So it will become 1 upon log of x to base 6. And then multiplying throughout by log of x to base 6, get a quadratic. So let me give you some problems for practice. So here you have to find the value correct to three significant figures. So first one is log of 5 to base 4. So you can just change the base to the standard base 10. Second, log of 10 to base 7. Now here, just keep this hint in mind that log of 10 to base 7, take the reciprocal, it will become log of 7 to base 10, which is just log 7. Okay, then third one, log e to base 5. Now since this is e, change the base to e, that is the natural base. So you can write log e to base 5 as 1 upon log 5 to base e, which is nothing but 1 upon ln e that you find on the calculator. And this is first one. Second, solve to log x to base 5 plus 5 log 5 to base x is equal to 9. So obviously here log of 5 to base x, take the reciprocal and write it as 1 upon log x to base 5 and then get the quadratic. So wish these steps are okay with you. Try these problems and any doubts, please ask me in the next class. See you students. Enjoy the day. See you in the next class.